Now, the third one is solving quadratics by completing the square. Honestly, completing the square is basically like you're going to turn it into a isolation problem is what ultimately is going to happen. It's one that can't be factored, and you don't necessarily want to use the quadratic formula or things like that. I would say if you're going to use completing the square is going to be more beneficial for you whenever you're trying to graph a quadratic, probably more than you're trying to solve it. It works just as well, but it's probably a little bit more beneficial whenever you're trying to graph it and not always whenever you're trying to solve. So just like it said here, basically what you're going to do, whatever the variable is or the coefficient in front of your x value, so you have your x squared, then you have your bx or your middle term, that number is going to get divided by 2 on each side, or get divided by 2 and then squared to each term. Okay? What I'm going to do is we're going to write it as a binomial squared, and then making sure that whatever we do to the left side, we do the same thing to the right. So if I have x squared minus 6x plus 4, and you have a trinomial, maybe the first thing you do is you see, are there two numbers that I can factor to multiply to give me 4 and combine to give me a negative 6? Well, there's not a value. 4 and 1 do not work, and 2 and 2 don't work. So if you're not going to go about quadratic formula, then your other option is completing the square. So what you're going to do is, the first thing is I'm going to get the 4 over by itself. So I'm going to have x squared minus 6x plus, and I'm going to leave myself a blank, and I'm going to move the 4 over to the other side. So it's going to be a negative 4, and then I'm going to have a blank. Whatever I have here in this space, I need to have the same value right there. So all I'm going to do is I'm going to take negative 6, divide it by 2, and square it. And I'm going to take negative 6 and divide it by 2 and square it over on the other side. Now, on the right side, it's going to be fairly simple. It's just going to end up being negative 4 plus, well, that's negative 3 squared, which is really just going to be a positive 9. Okay, so I'm going to have negative 4 plus 9, and then, so it's going to be 5 on the right side. Now, on the left side, what I'm going to do is I'm just going to shortcut this. I'm not going to try. What I could do is I could have x squared plus or minus 6x plus 9 and then factor it from there. But all this is going to turn into, so if I have x squared minus 6x plus 9, that's just going to factor out, because it's a perfect square, hence the name completing the square, it's going to be x squared plus 3 squared. Or minus, excuse me, not plus. So minus 3 quantity squared. Now, it's equal to that 5 that I have over here. It's just going to turn into an isolation problem. Now, there's an easier way. I don't do this step normally, okay? Because all I do is I take that negative 6 divided by 2. Negative 6 divided by 2 is negative 3. Amazingly, negative 3 is right down here in my binomial. So I'm just going to rewrite it. I'm going to have x minus 3 quantity squared equal to 5. Again, like I said, it's going to turn into a isolation problem. Okay, is all we're doing. So just like we did on the very last problem, we're going to square root both sides, and I'm going to have x minus 3 equals plus or minus the square root of 5. Add 3 to both sides, and then x is equal to 3 plus or minus the square root of 5. Nothing changed. It's the same thing that we just did. The biggest step is really making it a perfect square with this value and here. Okay, and making sure that that 9 gets brought in with the 5, and so on.